All right, so the first thing we're going to do is bring in a rectangle. So I'll double click here in Grasshopper and bring in a rectangle component. This rectangle component will let us pick an X and Y size for our box. So now let's plug in two numbers in the X and the Y, and that way we can change the size of this rectangle. So we got a 50 slider with 50. When you type in 50, it'll go from 0 to 100, and then I'll slide it down, tap Alt to create a new copy. This way we can plug a separate number for the X and Y, and now we can create a rectangle as you see here. The cool thing is that we can change the sliders and this will update. So the entire design will be based off of this. Now we're turning this into a surface. And from this surface, we're going to extrude it in the Z direction to give it a height. So I'll take this, slide it here, tap Alt. Now we have a new slider for the height. And I'll disable the preview on that surface. Now that we have this box, now we can move on to selecting which one of these faces is going to be the first one we're going to develop. So the way to pick an individual face is bringing in deconstruct brep. We're going to pick one of those faces. So the way to do that is we can actually see the number if we do a point list, but for now we'll go to list item, and when we hover over the outputs, you'll see we have 6 surfaces. That makes sense. Then we have edges and vertices. We'll be using the faces, and now since we have 6, well, we can create a slider from 0 less than 3 less than 5, because from 0 to 5 there's actually 6 numbers. And now when we plug this in, we can actually go through all of those, starting here and moving to the top. So what we're going to do is pick opposite faces and the base. So here's the idea. When you have a rectangle, you have a symmetrical faces when it comes to the ones that are parallel, but you also have the bottom one. So what we'll do is we'll pick this one. I'll slide it down, tap Alt, including the slider. Actually, let's undo that. Now we'll go to 1, which will pick the opposite face or the one that's next. And then we'll tap Alt and bring this down again to pick the bottom one. So let's cycle through them. There it is. Okay. So now let's take these, disable preview, and let's organize this a little bit. Now here's the thing. These are consistent, so we're always going to be picking those. So if you, let's say, save this script and then move this slider, well, you're going to mess up the whole thing. So one way to do this is, let's say you pick those and those are the correct ones. You can right click, internalize data, which will take away the slider and actually place that number inside. So 0, and then we'll go internalize data. That 1 will be internalized here. Same with this one. So what that does is it makes it easy for me to get rid of the sliders that I know are only picking specific items and just focusing on the ones that I know change the design. So if we move this around, we picked the opposite face for each one. Okay, cool. So with these, now we need to start figuring out how we're going to take away from one side and give to the other side. So what we'll do is we'll start with this side. Actually, we can start with any side, to be honest, but we'll start with this one, actually, just the first one. What we'll do is we'll take this and we'll have to pick, in the same way that we picked the faces of the box, we're going to pick the edges of this box. So to do that, we're going to take this and do the same thing. Deconstruct brep. And what is brep? It's a boundary representation. So all it is this surface represented as the boundary edges and the surface on the inside, which we can deconstruct into the edges, which is four vertices and one face. So what we'll do is actually pick an item, so list item, edges, into the list. And now we need to pick one side and the bottom. So now we know that index of 0 is the bottom. So index of 1 is going to be either this one or this one because they're organized in a clockwise or counterclockwise. With that being said, we can also take this. We know that this is the correct one. Tap Alt and then go index integer of 1. 0 and 1. Okay. Now we can disable the preview on most of this stuff. And the bottom line segment. So now we're just looking at the stuff that we are developing, which now that we have this line segment, well, we can subdivide this so we can create the pockets. All right, so let's do that. Let's take this line segment and let's divide it. So we'll go here to divide curve. And it's going to ask us to divide it by how many. So we'll just go here to, let's say, 5. Okay. So now that we have these 5 points, we're going to take these points and actually create a box here that overlaps with this surface. But what happens is we actually don't want the bottom or the top. So here's a trick that I learned from actually one of the viewers. They're like, oh, there's an easier way of doing that. Why don't you try this? So thank you for teaching me that trick, and now I'll be using that all the time. So it's called col index. And if I put these points into the list, it's going to ask me which ones do you want to remove. And if we go here to a panel, so quotation marks, 0. Then we'll go enter, less than 1. What it does is it'll remove the first one and the last one. So once we have this, we can hit OK. Just make sure that it says multi-line data, and then we can plug this into this. I had another trick that I've used, but this actually is pretty efficient. So with this being said, now with these points, we can actually start developing what we're trying to do here. So next part is, since we need to create the rectangles here, we need a reference plane to place those. So if we take a look down here, we have the X, Z coordinate that we need to align it with. So we'll do that. We'll bring in an X, Z plane and place it right at those points. So in the same way the rectangle down here was created at the XY of the origin, well, these are created at this origin using these planes. Let's now type in rectangle. And now we'll be creating another set of rectangles, but now on this plane. Now you're starting to see like what I'm doing here is we're starting with the base geometry, creating base planes, and then we're creating new objects here that are going to be subtracting from it. So with this, now what I need to do is make sure that I shift it over in the negative X direction. So let's say if the objects here, or if the rectangles here are going to be 10.5 by 10.5. Actually like to decrease that. Let's do that again. Let's create a custom slider. We'll go 0 less than 5 less than 15. We'll make sure that the X and Y size are here. Notice that when you plug those in, they'll actually be moved to the outside. So we need to take this box, move it down by half, and to the left by an entire X direction. And you'll see how this works. So we'll move these rectangles but they can't just be moved. Well, actually they could be just moved in the negative X direction. So we'll go X, negative, and plug in the number for the X direction. So 5. Oh, okay. So we'll move this by 5 in the negative X direction, and by negative Z by half. So Z, notice that it's only to the middle, so divided by 2. And it's going to be the Y direction that is half. So the Y direction here is actually Z direction in the origin. So now we'll take this and copy it again, but move this rectangle in the negative X half way, like this. Okay, so now that we're here, let's disable the preview on the original, disable the preview on the planes because it can get in the way, and get rid of this one because it's before we moved it down. And this is actually where we wanted it the whole time. It's just, I mean, we can plug in, there are other ways of doing this. I just gotten used to doing it this way. So let me show you this way. All right, so we got those. Now, how do we change this? Well, we can change this number, change the size, or we can change this to change the height. But just know that this X number, I like to double click on the output here to get a relay. This number is going to be tied to the depth of that other material. If this material, let's say, is 5, well, the depth of this would need to be 5. So with that being said, let's do one thing to see what this looks like. I'm gonna move this down here just to get it out of the way. And now we're going to use region difference, which is subtract from this original surface that region, which is going to be all of these rectangles. So region difference is the same thing as Boolean difference, just in 2D. So now it removes that. Now we can disable the preview on all of this, including the original, and create a boundary surface here where we remove this side. Now, obviously, we need to do the other side as well. So what we'll do here is create a center point. Let's see here. We need to look for this bottom line segment, then bring in a midpoint. Because now that we have the midpoint, we can create a plane to mirror this to the other side. We could also move it, but using a mirror component, you just have to know what plane we need to create. So we know that this is the YZ plane. So that's what we'll be creating, a YZ plane here. And that's going to be where we mirror it from. And we will be mirroring these objects and also using those to subtract from. Here's the thing, I definitely don't like to see all these wires that cloud some of the logic here. So what I do is right click, wire display and hidden, and same with this one. just to keep things neat and organized, you'll also be able to select the component and see exactly where it plugs in. Okay, let's move some of these around and you'll see that we still have the ability to do some of these things. Now the next thing is tying this depth to the material size. So let's get into it. All right, so now let's look for the side, the other side. Let's go back here. We know we have this line segment. So these are the line segments. Let's go back to this. And now, okay, now that we have this surface, let's extrude this surface. Now, I do like to sometimes, if these are main surfaces, I do like to bring them out as individual surface components. These are empty surface components that we can place the surfaces into. It just makes it a lot easier and, you know, a little bit more organized. So we can use these surfaces as the, you know, this is going to be the X side. Oops, let's do that again. Group, Control G. You can change the color if you'd like to whatever you'd like. Go here with a lighter gray. And you can make that your default color. So now we can change this name to the X face. This one's going to be the Y face. And this is not necessarily, you know, something critical to do, but it is under the category of organizing your information, so you can use it again later. So here we'll go base, surface. I'll move this up, select them all, do the middle one, which actually this one, and this one centers it. Now I'll also wire display hidden, so it's not overlapping and kind of looking confusing there. So now we can take these. We're going to disable the preview on this one because we don't need it. Now this Y face, now that we've organized it, we're going to extrude it. Even though we don't yet have the subtractions on it, we're going to extrude this in the X direction, which is negative X direction, because if you see here, negative. And now a number. Let's go here to 3.5. Okay, so now this is going to be the depth of the Y face. So I shouldn't necessarily change the name because sometimes I'll copy this for another one, but this will help me know which one it is. So if that's the depth of the face of Y, well, this number is actually the number that overrides this number. Right? So now we'll go here 3.6. And even do this. Bring in an empty number component. The reason why I like to do that is here, I want to disable the preview of the wire to be hidden, but you can't do that with the relay. So I end up doing this. Wire display hidden on this number component and plug this in. That way it doesn't show that wire, but it, you know, keeps it a little bit better here. And also we know that this number, you know, we can type in Y face depth here if we wanted to. Okay. With that being said, this vertical we can still change. Okay. Now that we have that portion, what we need to do now is extrude up the base portion or extrude it down. So what I'll be doing in this one is actually extruding it up. The reason for that is because we're still staying true to the outside face numbers and dimensions that we have here. If I were to make it 50 and you extrude it down by 2, well, it's actually 52 overall. And that's not as convenient as having the numbers be exactly what you are looking for in terms of the output. So with all of that being said, we're going to take the base surface and extrude it up. So I'll copy this, but you'll see why it's not necessary to have the X and the negative. We're actually going Z positive. And for this script, which is going to be a little bit different than the last one, the difference is the bottom plate, I'm making sure that it could be a different number. In the last one, I had the sides and the bottom one be the exact same depth. And you know, that's okay, but sometimes you want the bottom one to be a different size, and we can do that with this one. So with that, let's take this and extrude it, use the base one to extrude up. And we can also subtract from this one. Let's change the depth here. We'll just say 2. But notice also that once you do that, then if you have more subdivisions, the subdivisions are going to start going into it, and you'll actually have a bit of a different one at the top than at the bottom. So these are the things that are kind of seeing here. Here's what I noticed is that since we do have a bottom plate, the top and the bottom of this are not going to be symmetrical. So this is what we need to do. If we're basing this off of this rectangle and this line segment, well, we need to shorten this line segment by the depth of the bottom. So how do we do that? We're going to now move the script over because we need to interject in this area before we move forward, right? This line segment needs to be, and this is when I create a full tutorial or a time-lapse tutorial, these are the things that I want to explain, but sometimes I don't get to unless I do a full tutorial like this. So with this one, we'll do an extend curve. Why? Because there's a start and an end point. And now we can use the number, let's say 2, which is how big the bottom plate's going to be. We'll do 2.0, and we'll do start and end. But one of these has to be 0 because the start, so you'll see here, this one's, the start is down here and the end is down here. So we actually have to do -2 and 0. This number is the depth of the material. So you're going to start seeing that here. And the reason why I laugh is because some of these things are pretty interesting and unusual, but the way that we shorten that's the same way that we are going to extrude the base by. So what we do now is take this curve that we had before this one, and now we use that one for the subdivisions. So this is symmetrical, and now we're going to be creating here the subtraction. Let's see here. Yep. So that's the bottom plate. And all we have to do is the same thing that we did to the sides, we'll do to the bottom. So let's do that. A wire display hidden. All right, let's go to this line segment now. And with that one, we're actually going to also shorten it relative to the outside material depth. So we'll take that, also extend, and now we'll be extending with the material depth from the wall side. So this is extruded in the X direction by 3.6. Well, this is going to be shortened so negative at the start and end, because we actually want to shorten it here and shorten it here. And now we can use this value of the 3.6 to, even though this says extend curve, well, we can also extend it in the opposite direction. So shorten it. And actually that could be extend or shorten curve here, but all right. With this one, we'll do the same thing. We'll take a subdivide curve. So I'm sliding it, tapping Alt to create a new copy. Now we have these subdivisions. These subdivisions are going to be done the same way, but what happens is we need to take a different approach because we're moving things in a different way here. And we're using a different reference plane. So this removes the first and last. This gives us the X and Y planes. We can actually internalize data on this and internalize data on that. We won't change those. Now here we're going to be creating the rectangles. So once again, rectangle. Let's pick the numbers. So the width of it, so this is going to be the X direction. We can pick whatever number we want. So let's use the same width, so 2 for the X direction here. Now we're going to move it -½ in the X direction. So negative and then divide by 2. So which number? It's going to be the one in the X direction here. So this number divided by 2. In the X direction. Oops. This will go in between. Oh, no, so this value is that, and we move that rectangle in the opposite halfway. Okay, now we're going to move it up by half. So move, well, the X size is going to be the size of the material depth at the bottom, which we know is this one. We shortened it, and also this depth is it. So with 2, we'll be moving that, let's see, 2, the Y size is going to be 2. And now that we have that, then we have to move it -X. We got it there. Now we got the value of the height. So actually that's all we had to do, because the height is going to go positive and then halfway this way. And now we can add this to the region difference. So the number of divisions at the base will be different. They will be the same size because we have these tied the same way. And actually on this one, let's go to a range of numbers with like 3 decimal points. And then change. All right, so at this stage, look, we've done all of this to basically create this side plane. We created this bottom plate and the side plate as a reference for us to see how we are going to tie these notches to the material depth, which is going to be the sides are one size and then the bottom is going to be a different depth. So that's what this does, is make sure that even though, let's say we have a really big base there, all the numbers are going to tie, including how this shortens as that increases. So this is the power of parametric design, is you can create these really cool algorithms, scripts, or programs for your designs. And as you get more experience, you'll be able to do that with, you know, all of your designs. So with that being said, let's get into the next portion, which is continuing to develop this to get the subtractions on the other side and to get everything tied together like you've seen in the previous scripts. So let's get into that. All right. So we've set the stage for this one. So let's extrude it the same way that we extruded this one. But instead of in the X direction, it's going to be in the Y direction by a positive Y. So extrude, direction, Y, and by the amount, this amount. So the same as, we can make them different. Okay, so that's the other thing I was going to say, is if we want the depth of this one to be different to the one on the other side, we can do that because the trick we're going to use is using subtraction. So regardless, we can program it that way. All right, let's do it. Take this, disable preview. Now we're going to pick this bottom line segment. So if we took this extrusion and we got that side, but we also have our base rectangle. So we can use some of that. We'll go to explode. I'll use this, create a relay to make it come out from that. Sometimes I want to be able to replace the rectangle if I wanted to. We'll plug this into the curve. We'll see that it is exploded, which means that we have 4 segments. Let's pick one of them. Picking the first one, 0 is this one. So if I go to 1, it'll for sure be one of the side ones, because it goes 0, 1, 2, 3. So it could go 0, 1, 0, 3. So with this midpoint, and now which plane would we create to mirror this? YZ plane, created right in the middle. Oh, incorrect. XZ. And from there, we'll mirror to the other side. So taking this, we'll go to a mirror component, plug in that plane. Now we're plugging in the other side. All right, cool. So let's see what that does. Let's take these two and subtract it from this face. Now, let's disable the preview on this. Solid difference. We'll pick the wall we want to subtract from and the subtracting objects, which will be these two. So now we have the interlocking sides. Let's see if we can hide. It was these surfaces that were in the way. Okay, now you can see that we can also take that and mirror it to the other side. So taking this and using the mirror component, but we actually need to do it from that plane that we used. Let's see here. We can use that same mirror plane because I know we had used it before. So we'll wire display hidden and bring this over. Let's bring back the base plate. And now we need to focus on creating the notches at the bottom for this one, for the base, that will be subtracted from the side panels. But first, actually, let's subtract from this one, these two side panels. So difference. And then this, and holding down shift, I can add another input. Now we have the base plate. So let's hide these so we can see it. But we need to now subtract, do the same thing, but do it in from the top view to subtract using the rectangles, moving it in the depth of the material, and then extruding it the height of the material and subtracting that and adding it to, see here, and adding it to this. Or actually, a different approach would be creating it for the side panels, and then subtracting it from the bottom. I think that's a better approach. Okay, so let's do that. We'll bring in the Y face. We'll go to list or deconstruct brep. We'll be picking the bottom segment, so item, the edges. We'll go create an index, move the index here, see which one it is. So 1, and then we'll internalize this. Now we need to extend or shorten this, so copy the extend. but we'll be using the start and end to be negative, which we kind of have already, but we want to make sure that the number we use is the same number as the depth of the walls. So here we have 3.6. That's what we'll be shortening this. Now we'll divide it using this, which we know that it removes the start and end. Okay, so now we need to create a reference plane to create the rectangles. So it's going to be a YZ plane. Now we need to create the rectangles. Now the rectangle we know in the X direction we can pick. So we know that this number changes. So let's say we'll make it 3. And this 3 is actually the 3 for the X direction. And the Y is going to be the height of the bottom plate. So if this number is 3, okay, so what happens is this one is the same number. It'll mess me up. Okay, so if this one is 3, which is the size in this direction, and this one is 4, then we need to move 4 in the negative Y direction. So move in the negative Y direction divided by 2. It's only halfway. So this size X and Y okay, so it's the Y direction that gets, I created a relay here as you saw to make it go there and here, and we can use that in those locations. So how far do I bring this out, bring this in? Well, we're going to use trick here, which is region difference. And we'll subtract these from the original surface, which is this Y face. Now, well, this is old. This will be old as well. And now we can subtract the region here and create a surface. So boundary surfaces. And then extrude in the same direction. So take this, copy it here, and plug that base surface into it because we're extruding it in the same direction here. Okay, we're making good progress here. Where are we overlapping with this one? So now notice that we have this subtraction, which we can actually use this one and disable the preview here, and you'll see now we have this. And we're going to also mirror that to the other side and subtract the bottom, which is this one, or this one that ends up here, and subtract All right, let's do it. Subtract, which means solid difference in Grasshopper. This one, which we want to keep, and subtract B. So A minus B. And then minus this other one. Holding down shift, I can add this other input. And now, finally, we have these, the bottom, the sides, and these two sides. The cool thing about this is that they're all tied together, right? Like the number of divisions are in this direction. And we can tie them all together to make the exact same ones, but what happens is the aspect ratio is different. So in some instances, you'll have more in the X or less in the X or in the Y direction.